Hey, what's up, everyone out there in internet land? It is me, Kris Nova, doing my first live stream from here at the office. I was going to be working from home today, but I came into the office and decided I was going to set up a small recording studio here in the San Francisco office, and we'll see, one, how hot it gets in here today with my hardware encoder on, and two, if we are able to retain power or not throughout the stream. So my normal home recording setting is in boxes somewhere in Oregon right now. So I'm using my work laptop. So this is the first time I've streamed on this, so we're gonna have to go through and kind of do the song and dance here to make sure everything is up to speed. I'm gonna crack this door so it cools off a little bit in here. Just to make sure everything is up to speed and working, and I want to see that, we obviously have a chat and that folks are getting a video and that we're recording on YouTube. So that's going to be the first thing we do, and then we're going to jump into learning more about OPA and Gatekeeper, and I'm going to try to install it and get everything up and running. So I think the first thing we want to do is I want to turn off Tools, View. So I'm trying to do OBS in a different desktop. So I want to turn off my live view screen here so we don't get that weird recursive video thing. So let's see here. Enable preview. Oh, perfect. Okay, cool. So now I should be able to flip over to full screen, and let's go back to my main window and see what's going on twitch.tv and see what folks are seeing there. So here we are on my main screen. And let's go to twitch.tv, and let's see if I can't hear myself. Also, our internet here at the office has been acting up this week, so that might be another caveat. But regardless, I knew that if I was going to book a live stream for myself, I was actually going to force myself to do it. So this is our first one here, of many more to come. So we're going to start doing this a lot more. So this is kind of the first bypass here. Okay, so let's see. Let's go to let's go to my channel, and let's see what's going on. Okay, great. So now let's make sure I can hear myself.
One up top, two on the bottom.
I don't know where that was coming from. Oh, we definitely don't want that. Oh, okay, interesting. That's the weird recursive thing. Okay, cool. So I think we're good to go. Let's make sure we have chat and see if there's anybody hanging out in the chat app. Doesn't look like we see anyone here, so hey, what's up, everyone? Oh, we have 9 people here. Let's see, or 7. I think we can go to let's go to creator dashboard, and let's check out the chat here. I like the Twitch chat the most. And if folks have suggestions for things for me to try, please let me know. So stream chat, let's pop this out. Move that over here. And we can close that one, and that one, I think. Let's see. Yes, and we can also close this one and this one. Oh, it looks like there was people in the chat. Let's see what's going on. Stream chat, nope. Let's try the restream one again. Launch chat app. See what people have to say. Hurry, the chat is waiting for new messages. Oh, I lost the old ones. Let's just see if we can't do, hey, can everyone hear and see my screen? So we'll come back to this one. Let's get a terminal set up, nice and big. I'm running Arch Linux. We all know that Arch is my favorite way of torturing myself. And I can talk more about what I'm running and what's installed on my system and what all we have up and running here in a little bit. Let's make sure my Kubernetes cluster is still working. And it is. Let me clean up some stuff really quick. Kgit deploy. Kgit pl. Kgit daemon set. There we go. Delete daemon set zlog collector. I was demoing some software the other day and that's still installed. Okay, so let's see if anybody said anything in chat yet. Victor Jimenez. All right. Hey, Victor. Good to see you. Thanks for joining. Today we're going to be messing around with OPA and Gatekeeper. And anything else you or anybody in the chat wants to see. I think my first concern here is being able to make sure that I'm going to have this tab open, so I'll be able to get back here so I can see what folks are seeing at any time. So yeah, I wish I could see like down here who is joined. It says 6. Maybe if I go to dashboard. Nope. Okay. Well, anyway, thanks for joining, folks. Looks like we have 6 on Twitch and 6 in YouTube, or 2 in YouTube. Cool. So yeah, let's just jump into this. I don't have much time. I got a meeting I got to run to, I think, at 2:30. Let's make sure. Oh, it's at 3. Okay, so we have more time than I thought. That's really good. And then real quick, I'll jump back over to this screen. And I'll come here, and I'll be like, hey, it's good to see everyone. Thanks again for joining. We just spent the first few minutes here going through making sure that YouTube and Twitch and everything was all kind of dialed in for our first rendition. I'm going to try to contribute as much of this upstream as possible. In fact, I can show you that right now. Let's go back to my full screen. And let's go over here. And let's go back to Chrome. So if you go to github.com/Falco security/community, this is where we're going to be tracking all of our live stream information. In fact, let's go ahead and just create a new one now. So we're going to call this one OPA Gatekeeper. So actually, let's give it a number. Live here. /001 OPA Gatekeeper. And then I'll do Kris Nova. There we go. Dot markdown. Cool. So we're gonna do first episode, dialing in Twitch and YouTube. And I think with that being said, we can take notes here if folks want to follow along, and we can do that. This is pretty cool. If you haven't installed this yet, you should really check it out. It's a cool new gadget, or I guess I should say feature you can install. Oh, and Prowl's gonna yell at me. So we have Prowl set up, which is a good thing because it prevents people from doing what I'm trying to do right now, which is be lazy about how we're contributing code to the repo. So I'll have to come back and sign off on this commit, I think. Yeah, see, it says commits and missing PR signed off by. So I can do this manually, but that's just going to be a pain. So I'll show folks a different way. So we already have a markdown file created here in live streams. So for today, we could just use this readme.md. And this was the button I wanted to show you here, this edit on hackmd button. So feel free to join along and take notes with me. We'll update this and that other PR here after the stream. And I can share this link in our Restream chat if folks want to join and follow along and take notes. It would be helpful. Okay, so first things first. Let me give you a little bit of context about kind of me and why I'm doing this and what OPA it means to me already. So the whole inspiration for this came from some conversations we've been having with folks in the industry about Falco and about how it plays into what's going on with OPA. And so every time we bring up what we call Falco rules on our end, or even talk about this thing called RPI that we're working on, almost immediately the follow-up question is always, okay, well, what about OPA? Have you looked at OPA yet? So what's going on there? So I've heard a lot about it, and I've done very, very minimal research because I wanted to sort of encapsulate the rawness of discovering software for the first time, if OPA really even is software, if it's not just a spec. and kind of just talk about my thought process as we go through exploring what OPA is. And hopefully when we get done with this, I'll be able to like articulate this very quickly and very easily to someone. So within the next, let's say, 1 to 2 hours, we're going to go from me knowing almost nothing about OPA to me being, I'm not going to say expert, but me being somebody who can articulate what it is and what it solves very quickly to somebody on the street. So that's kind of the goal of today's episode. And then if we have time, we also want to look at Gatekeeper and see how that fits into everything as well. Okay, so let's go back to my full screen. And let's jump back over here. And, oh, Leo's here. Hey, Leo, good to see you. Good to see you. Cool. And again, once I have my desktop set back up, I'm going to have like my good microphone and I'll have multiple screens, so it'll be a little bit more like my traditional stream that folks are probably used to seeing on my Twitch channel. But for today, this one should be fine since I'm sitting here in the office. Okay, so first things first, let's just Google OPA, right? Let's do this. OPA, Open Policy Agent examples. Okay, so this is always like an interesting part of when I start evaluating software. There's two main approaches here, or I guess 3 depending on who you are. If you're a visual/video learner, looks like there's already some OPA talks that you can probably go and watch and probably learn a ton from. But for me, somebody who is more of a hands-on learner and likes to kind of just run things and install things and set them up and see what they do, there's always 2 avenues that you can usually go down. One is the GitHub avenue, which is just jumping straight into the repo and seeing what you can find. And the other one is going to the documentation website. And if you go to Google and you actually type in Falco security, we have this exact same situation, right? So here is falco.org. Which is our main docs site and like our main blog site. So if you come in here, you can see, you can download Falco, you can see our docs, you can read our blog, you can even learn what the project's about. And if we go back, you can see here github.com/Falco security/Falco. And if we keep scrolling, I bet we can find some videos and some other pieces of content about Falco. Okay, so repeating that with OPA, you can see already, so they've got a bunch of CNCF videos here. So I think this is our first to-do item for Falco, is get all of our Falco videos into the newly created YouTube. Let's see if we can pull this up. YouTube.com, into the newly created YouTube channel for the Falco project. So if you look here in the top right, I'm logged in as Falco. And if we come over here, we should be able to go to YouTube Studio and see my live stream. Videos. Let's click on live. Okay, cool. So this is us right now. So actually, let's just pull this up and see what happens. Okay, cool. So this is close. Can I see like the chat anywhere? We don't have a playlist yet. Let's create a playlist. Title, we're gonna call it OPA and Gatekeeper live stream. Create. Oh wait, no, we don't want that as a playlist, do we? Done. Okay, second action item for me. Come through and tweak our playlists. Dismiss. Let's go back to your channel, leave. Oh good, we didn't save it. Playlists. So let's delete this playlist. View full playlist. We can just change it here. We're just gonna call it live streams. Cool. And so now we can start adding our live streams here and generating more content around what we're doing here at Falco and at Sysdig. Okay, yeah, and I guess that's a good natural segue, right? Like, so hi, my name's Kris. I work at Sysdig, but I work on Falco. There are a bunch of similarities between Falco and Sysdig, and that's probably a different discussion for a different day. But like the TLDR is Falco is a completely open source project that I'm working on, and we just happen to use some of the same technology behind the scenes in our open source project that a lot of the folks at Sysdig have been working on and are using for some of our commercial offerings. So we're using the same open source libraries is basically what it boils down to. people are messaging me, I'm gonna just pretty much only respond here in this chat. So if you need to get to see me, or if you need to see me or get a hold of me, this is where we can do it at. Okay, cool. So let's go back to OPA. And I'm gonna start here at openpolicyagent.org. Okay, policy-based control for cloud-native environments. So there's documentation, there's a Kubernetes guide and tutorial, there's an Envoy tutorial, a Kafka tutorial, and it looks like they have an OPA summit. I'm gonna go with the Kubernetes guide and tutorial just to see what's going on here, and also because I kind of live, die, breathe, and think Kubernetes these days. Okay, so in Kubernetes, admission controller enforces policies on objects during create, update, and delete operations. Admission control is a fundamental policy of enforcement in Kubernetes. For example, by deploying OPA as an admission controller, you can require specific labels on resources, require container images to come to the corporate image registry, require all pods specify resource limits, prevent conflicting ingress objects from being created. So basically, what I think is going on here is we're using this concept called admission control in Kubernetes, which allows you to define pretty much anything you want and enforce that. Where did we go? Did we overwrite our tab here? We did. Let's go back. And enforce this concept of admission control during create, update, and delete operations. So third action item for me, we need to get me a whiteboard or like something I can draw on and like project it up on the screen or maybe on your stream on your end. But yeah, basically what I'm starting to think of here when I'm thinking of OPA is it's basically a piece of software that you can run in Kubernetes or anywhere for that matter. And during create, update, and delete, you can require that there's arbitrary things set up in your cluster. Which is handy because you can start to do things like enforce arbitrary policy. For instance, this example here, require that container images come from a specific image registry, which would be helpful because that would prevent folks in your cluster from just running random images downloaded from the internet in your Kubernetes cluster. So I think off the cuff, the main sort of difference here between OPA and Kubernetes between OPA and Falco rules is OPA is ran whenever we are making changes to cluster configuration. So in other words, if you were to like take, it's not called Arc anymore, I don't know what it's called, but it used to be called Arc once upon a time, but take a dump of all the configuration in your cluster effectively, and if you were to mutate that, that's when OPA would sort of take action and enforce that any of these operations are in compliance with whatever arbitrary policy you have set. So let's keep reading and see if my assumptions are correct. Admission controllers also commutate incoming objects. Aha, I was correct. By deploying OPA as I guess that's another good question. Is it OPA or is it OPA? Is it OPA? Is it, I don't even know. So by deploying OPA as a mutating admission controller, you can inject sidecar containers into pods. That's mildly worrisome, but I'm going to keep going. Set specific annotations on all resources. Rewrite container images to point to the corporate image registry. Okay, so we're actually able to mutate objects. Yeah, you can also mutate incoming objects. Include node and pod anti-affinity selectors on deployments. Okay, so in general, I'm gonna kind of get up on my soapbox here. And in fact, let's really get me on my soapbox. In general, going back and reading what we have here, it said admission controllers can also mutate incoming objects. And to me, as a software engineer, another way of saying that is calling that magic. Effectively, it's you as an engineer create some sort of configuration or some sort of tangible artifact, and you go and you say, okay, now run this artifact, and then doing like some sleight of hand magic trickery, there is this mutation that you probably don't even know about happening behind the scenes that may cause unexpected behavior for you and your project. For instance, if we were trying to run an Nginx pod in Kubernetes that had some very specific configuration. Maybe we recompiled Nginx with some new flags. Maybe we're working on developing a feature for Nginx. The point here is that if we had a version of Nginx that we had created locally, and we would like to run that in a Kubernetes cluster, and we were using something like OPA, and we had configured OPA in such a way that it would be used as an emission controller, then there is a possibility that the image that we told Kubernetes to run is not actually the image that gets ran. And that's the magic that I was sort of talking about. So like there's good things and there's bad things about this way of enforcing policy. I guess probably the easiest analogy here would be comparing this to something like SE Linux, which is effectively a way for you to take preventative action before any potentially malicious or undesired behavior or configuration enters your Linux system. So we're basically doing the same thing, but using admission controllers in Kubernetes and using OPA or OPA as an admission controller. So again, there's good things and bad things about this approach. If you look at the Go programming language, what little bit of magic that slipped in there is highly scrutinized and highly frowned upon by most people in the community. And that's going to be anything like global state or init or the way that we download packages using GoGet from potentially undesirable repositories. And so again, this is just like it's a preference thing. It's like picking out, are you a truck person or are you a motorcycle person? Like it's totally up to you. It's a personal decision. For me personally, I am one who would err on the side of I would prefer verbosity, and I prefer things to be as literal and non-magical as possible when I'm interfacing with software. So that's my spiel about OPA and the magic of taking action on mutating incoming objects. Furthermore, if you look at mutating an incoming object, if you were using something like, for instance, GitOps, which is supposed to act as a source of truth, and we were following that same Nginx scenario that we looked at earlier, I could have some configuration stored in Git that I expect to be running in Kubernetes, whereas Git is my source of truth, and OPA has done the bait and switch and did some sleight of hand when we weren't expecting it to, and mutated that incoming object without us knowing about it as it's running in Kubernetes, or in any environment for that. So anyway, let's keep reading here. Okay, so these are just examples of policies you can enforce with admission controllers and OPA. There are dozens of other policies you will want to enforce in your Kubernetes clusters for security, cost, and availability reasons. Okay, that makes sense. Let's check on the chat really quick before we jump into OPA Gatekeeper. Hey, good to see you. Hey, folks. How is everything going on your end? Audio, video, it's all fine? Let's see what people have to say, and while we wait for that, it wouldn't be a live stream if I didn't grab a Diet Coke and drink a Diet Coke live on the air. Let's see if we can't pull up. Let's go to twitch.tv. And we'll go to my dashboard here as soon as it wants to load. Let's see, creator dashboard. I'm gonna pause this so we don't get the weird recursive thing. And let's go to the stream chat. Let's pop this out. And I think if I click this button here, yeah, we can see here we have Lurks, Commander Root, Cloud Native, and a few other people hanging out. Let's go back to OPA. Okay, so what is OPA Gatekeeper? So it says OPA Gatekeeper, and there's a link. Aha, we're back in GitHub. So you can see they've already done that choice for us, whereas Gatekeeper is a small part of OPA, it looks like, and it just took us straight to the GitHub. Okay, so Gatekeeper, this is a policy controller for Kubernetes. So this is where I'm going to pick on Kubernetes a little bit just because, obviously I've been a big part of bringing it to life and making it what it is today, as well as a lot of other hardworking engineers who have done much more than I have. But anyway, we're starting to go off very, very specific tangents about things like policy versus admission versus compliance versus security versus observability versus obviously there's a lot of words here that mean a lot of different things, and there's really no playbook on what each of these words means. There are, however, first-class Kubernetes primitives that sort of tell you what the scope is for each one of these things. And in this case, policy is a very open-ended one, and admissions is another very open-ended one. And there might even be some overlap between the two. But let's keep reading about Gatekeeper to see if we can't understand specifically how this is different than using OPA as a admissions controller in Kubernetes. So it says, great, how is Gatekeeper different from OPA? Compared to using OPA with Sidecar Kube Management, aka Gatekeeper version 1.0, Gatekeeper introduces the following functionality: an extensible parameterized policy library, native Kubernetes CRDs for instantiating the policy library, aka constraints, native Kubernetes CRDs for extending the policy library, aka constraint templates, and audit functionality. Okay. Goals. Every organization has policies. Some are essential to meet governance and legal requirements, yada, yada, yada. Kubernetes allows decoupling policy decisions from their inner workings around the API server by means of admission controller webhooks, which is basically how an admission controller interacts with the cluster, which are executed whenever a resource is created, updated, or deleted. Okay, Gatekeeper is validating mutating TBA webhook that enforces CRD policies executed by OPA, a policy engine for cloud-native environments based on hosted by the CNCF as an incubation level project. In addition to the admission scenario, Gatekeeper's audit functionality allows administrators to see what resources are currently violating any given policy. Okay, so basically here's what's going on here. We have admission controller webhooks, which think of these webhooks as you would think of a git commit hook. It's a small piece of code or software that you would run or execute when you're trying to perform another action otherwise. And again, we run into these same concerns about magic with git commit webhooks. For instance, if I wanted to do a git commit and I had a bash script that was very quiet and very unintrusive, I could potentially take all of your data and push it to a different server. I could mutate your commit messages. I could mess with your syntax. I could replace all your lines with spaces. There's a lot of things I could do here. And as a software engineer, if you aren't aware of these sort of magical hooks happening behind the scenes, there could be some unexpected behavior that you are trying to figure out and you're not sure where it comes from. And in some cases, that can feel magical. Okay, so keep it on reading. So installation instructions. Okay, let's do this. Let's install this and see. Let's kind of go through this and see what happens. So kubectl create, cluster role binding, cluster admin binding, cluster role, cluster admin, and user your user name. So we're creating a cluster admin, which is basically like root user. That's like sudo on your cluster. So that's like the first thing that jumps off at me. So let's run this and see what happens. User, and we're gonna do Knova. Okay, cool. So we now have a cluster admin or root user called Knova. Okay. Kubectl apply, deploying a release using pre-built images. Let's look at this YAML and see what's going on here. Again, it wouldn't be a live stream if we weren't catting out YAML on the screen. Curl, duh. Okay. Let's see what we got going on here. Ooh, all kinds of goodies. Okay, so here's where we start. And that line there is the top of our files. So we created namespace called Gatekeeper System. We have some labels. We're creating a custom resource definition, otherwise known as a CRD. Type string, kind description. Okay, this is a CRD, which is basically a schema for an arbitrary Kubernetes object or resource, and you define it in the same way that you would define like a schema for MySQL, where you tell it which type of fields you want, what you expect in these fields, and what type these fields are. For instance, you can see we have a field called version, and in the version field, you can expect it to contain a string, whereas you have a type object for properties, which holds the version string we just talked about. And then we have an array of these property objects that we call items, and each of these properties objects have version as a string, as well as kind and group as a string as well. So you can sort of see how we're able to construct these very complex data structures using CRDs in Kubernetes. And it looks like, let's see this first one here. So API version defines the version schema of the representation of an object. We know that. Okay, so this is called the Gatekeeper config or configs. Okay, so this is part of the gatekeeper.sh, which I think is their domain. Items, properties. So we have a lot going on here with our CRD. I'm going to kind of skip through this because we're actually just going to pull up these CRDs after we install them here in a second, which I think is a much easier way for folks to look at what a CRD actually looks like. Let's check in on our chat and see what's going on. Everyone seems to say that everything's going great, which is good. Okay, so next we have API version, which is a kind cluster role. We have API groups, resources, verbs. Okay, so for API groups, that basically is saying every API group, every resource, we can git, list, watch, update, and patch. Patch is an interesting verb that you don't see very often in Kubernetes, so I'm happy to see folks are using it here. API groups, config gatekeeper.sh, which we saw this earlier in our CRD. And here for configs, we can git, list, watch, create, update, patch, and delete. So we pretty much have full flexibility over this specific resource, configs. It looks like we have that same pattern created for all resources in the API group, gatekeeper.sh. That makes sense. CRDs, same thing. More API groups, constraint templates. I think these are the constraints that we read about earlier for Gatekeeper. And mutating webhook configurations, validating webhook configurations. Okay, so we're basically giving Gatekeeper pretty much wide open access. Not completely wide open, but pretty darn close for this entire API group that we've created for it in this namespace, which, as long as we're keeping Gatekeeper hanging out in its own namespace, it's not the most invasive thing in the world. And then, of course, we use a cluster role binding to map that to something. We define a secret, which is not really a true secret because Kubernetes. And then we have a service listening on port 443, forwarding to port 8443. And then here's where we start to define our application for the first time. Okay, so we're going to run a stateful set, which is interesting because that usually implies we have some stateful data. Let's see what our containers are. So the first one, we define some environmental variables. Aha! So here is our Gatekeeper container. Quay.io, open policy agent, Gatekeeper, version 3.0.4-beta-.1. Image pull policy always, and this is our manager. And this is, of course, listening on that target port 8443 that we saw in that service just a moment ago. This is a very well fleshed out stateful set, I gotta say. It's got resources defined, it's got resource requests, resource limits. We're even mounting /certs as a volume mount. I mean, the only thing that would concern me here is exactly what this image is doing. And for the sake of this demo and for the sake of both of our time, I'm going to just assume that this image is fine and that we're safe to go ahead and run it. This is a CNCF incubation project, which again I think is probably an interesting thing to point out here. And for this one, I'm going to go back to my face because I'm going to rant for a little bit. So yeah, because this is a CNCF incubation project, I think there's some certain assumptions that an end user would have, which is probably one, this has been iterated on a few times, and it's kind of like bypassed that initial rough around the edges phase. So in other words, it's not a completely polished gem, but it's well on its way, and it's definitely not a raw rock or a raw mineral anymore, to use like a rock and mineral analogy here. So I think it's going to be okay to run this. I'm just going to go ahead and go for it and see what happens. What I would do if I wanted to test this out first is I would probably do like a Docker run locally and use a tool like, actually, you know what? Let's do this. Why not? We have enough time. Let's do this. Okay, so let's go back to my full screen. Go back over here. Let's grab the name of our image. I'm going to open up a new tab. Zoom in a bit for folks at home. I think that font size is good. So let's make sure Docker is running. Docker run. Okay. Docker run. So let's try to, the first time we run this, let's try to actually start an interactive TTY and see what we can get out of this. The name of our container /bin. We'll just try bash, and this might take a few iterations to see what's going on here, but we can start to poke around at it this way. So, unable to find image, it's going to pull it. Download image, error response from daemon, failed to create endpoint, silly brand on network, failed to add the host, operation not supported. I'm assuming this has got to be the admission controller webhook. So let's try to, we know it runs on port 8443, so let's try this. Error response daemon, failed to create endpoint. Do I need to run this as sudo perhaps? Nope. Interesting. Okay, well, I'm going to waste too much time on that. Let's see what happens when we run this in Kubernetes with our service, which, where was our service at? Here. So this is just, yeah, this is just mapping. The label selector here is control plane controller manager, and you can see here control plane controller manager. So we're mapping this correctly, and it's listing on port 8 here. Maybe we can try to do 8443 and see what happens. Failed to create endpoint. Nope, no clues from our studio audience. So we'll keep hacking away here and see what we can find. Okay, next we have more CRDs. Again, we're going to bypass that, and that's pretty much it. So let's install this thing and see what happens. kubectl apply -f the YAML that we just looked at. And even now there's an attack vector here because this could have changed from underneath of us, but behind the scenes. And I think to be very, very thorough with this, you would have wanted to download the YAML, look at it locally, and then apply that locally. But you can see here all the resources we just created are now installed. And our namespace here is Gatekeeper system. So we'll do our alias thing. So we'll say k gatekeeper is equal to kubectl namespace gatekeeper system. So now I can kg get po. And there we go. Let's see what's going on with these logs. kg, and then let's actually do a -f at the end. kg logs gatekeeper controller manager -0. Oh, there's an A here. There we go. All right, so good old classic JSON logs here. Entry point, setting up the manager, setting up webhooks. Yeah, so that was what was going on. It was starting to start a webhook endpoint. Installing webhook configuration in cluster. And let's do, for folks at home who don't know this command, I have basically alias kdump is equal to kubectl get all --all namespaces. And now if I run kdump, we can just see everything that's running in my cluster. It usually takes it a minute. Yeah, there we go. So it's handy because over here on the left, you always get the namespace first. So you can actually grep for Gatekeeper system. And you can see here, this is everything that we have running in the Gatekeeper system. Namespace has been highlighted in red in this namespace column on the left. So we have a pod that we just looked at. Here's that service. It's got a cluster IP, and again, it's listening on 443 and forwarding over to the target port 8443. And here's our stateful set, where our stateful set is defined. So very, very simple system here. So let's go back to our docs. So this is just getting it installed. We were working on a tutorial. How does it work with plain OPA? The Kubernetes API server is configured to query. So this is overview and architecture. I want like an actual tutorial now. Here we go, ingress validation. Okay, so let's try to kind of catch up with what we've already done, just getting it up and running and understanding what all this stuff is concretely. And let's actually try to run through a ingress validation tutorial really quick. Minikube start, we have a COPS cluster, create a namespace to deploy OPA into. So let's try to do this and create OPA now and see if the two start to magically find each other. So create namespace OPA. Okay. Set context OPA tutorial, user minikube. This is just getting our kube config set up, which we already have that. Deploy OPA on top of Kubernetes. So it wants us to generate some OpenSSL cert material here. So let's do that. So I will go to go source github.com Falco security. And we want to move this to this because we renamed the repo. Go into community, get branch, get checkout master, get reset hard, get pull origin master, and get remove -v. Get pull upstream master, that's why. There we go. Okay. So now I can fix that PR. But more importantly, we're going to generate our cert material here in this repo for our live stream. OPA Gatekeeper. Cool. Make their certs and go into certs. And let's run our OpenSSL command. Okay, so we generated that. Let's run this command. Okay. Generate TLS key and certificate for OPA. Okay. And more OpenSSL. So basically it looks like we're just creating mutually encrypted TLS for OPA here, which is exactly how we do things in Falco with our gRPC outputs that we've been working on. Oh, this is a 10,000 day long cert, which is good because normally my certs expire after like around 30 days. Okay, so let's create a secret from all this cert material we just created. Okay, our secret is created. And here's our admission controller.yaml. So let's see if we can't find. Here, let's do this. I'm going to just pull this up in my terminal so we can just do the same thing we did for Gatekeeper and we can see what, if any overlap is. So let's... So if we cat out opa.yaml, yay! Let's go here, and this is the top of our file, so I'll do that again. Let's check on chat, see if folks have questions so far. Nope, looks good. Okay, cluster role binding API version. So we have another cluster role binding. We have a role, another role binding. A service, that's it. Wait, did I miss? No? Okay, so next we define our service. This one's 443 to 443, not 8443. Here's our deployment. Let's see if we can't run the OPA container. This is running OPA latest. That's good to know. Warning, OPA is not running with an authorized policy configured. This means that clients can read and write policies in OPA. If you are deploying OPA into an insecure environment, be sure to configure authentication and authorization on the daemon. See the security page for details. Okay, so let's try to run this locally and see what happens. Okay, our Docker run IT, OPA policy latest, bin, bash. Let's see what happens here. Maybe this is more of a... Something's going on with Docker, I think. The PID isn't owned as root. Docker sock isn't owned as me. That all looks fine. Docker run Nginx. Yeah, so this is just a Docker thing. Let's see here. System, CTL, status, Docker. Running. Let's restart it. Docker run Nginx. Ah, very good. Okay, so now let's sudo chown nova var run docker.sock docker run Nginx. No, we got the same thing. Something's going on with my Docker. Not the time or the place to be messing around with Docker right now. Especially when we have a working, perfectly fine Kubernetes cluster. Okay, so here is where we're passing some arguments into the OPA, whatever. Latest image, we're telling it where to get the TLS cert file from /certs. I bet we're doing the same thing we did before with our volume mounts. Where we mounted, yep, -certs, it's here, it's read-only, that's true, that's good. And we tell it just to listen to on localhost 8181, that looks fine. Readiness probe, it looks like there's HTTP get has /health, which is not health Z. Kube management looks fine. Okay, we have a config map here, so let's see what we have. We have, okay, so this has got to be the OPA configuration language. I forget what it's called, but this is like, it's like, kind of looks like YAML, it kind of looks like JSON, there's a terminating comma, it looks like we're defining something called main. This looks very similar to the whatever the cloud native, Ballerina, that I reviewed a couple, like year or two ago. Okay, anyway, let's go back here. And I guess they want us to install that. When OPA starts, the kube management container will load the Kubernetes namespace. So yeah, let's apply this. The role config map modifier is invalid. Let's see. Name config map modifier API groups. It's empty. Must apply at least one API group. So I wonder if it says anything about this here. Oh, well, we found a bug in OPA. That's interesting. So is this admission controller.yaml? This is, yeah. So let's do this. I know you probably can't see this. I'm sorry about that. Okay. That looks like it went through. Okay, so when OPA starts, the kube management container will load in the Kubernetes namespace and ingress objects into OPA. You can configure the sidecar to load any Kubernetes object into OPA. The sidecar establishes watches on the Kubernetes API server so that OPA has access to an eventually consistent cache of Kubernetes objects. So it says we have Kubernetes admission, API version, API review, responses response, default response allowed true, response allowed false. This is very confusing. Reason is something admission deny. Okay, so I think what's going on here is we're starting to get into the templating language that is OPA. Okay, so let's see what's next. Next, generate the manifest that will be used to register the OPA as an admission controller. This webhook will ignore any namespace with the label rel. Okay, so let's create a webhook. Okay, so let's echo rel into webhook.yaml, and let's cat out webhook.yaml. Let's see what we got here. Oh, there's our CA cert material. That's good to know. Okay. Webhooks, operator not in, values ignore, match expressions, rules, creator update. Okay, so I think for the webhook here, this is a Kubernetes level primitive, and basically it's saying if you do a create or an update in any API group with any API version on any resource, we would like to, the policy basically here is match expressions, OPA policy agent webhook is not in, values ignore. So basically make sure that this key is not in this match expression for the namespace selector. Okay, so the generated configuration file includes a base64 encoded representation of the CA cert so that TLS can be established between the Kubernetes API server and OPA, so I'm assuming that's a self-signed cert. So here we go. Next, label kube system in the OPA namespace so that OPA does not control the resources in those namespaces. So this is where that configuration we just looked at comes into play. Remember, it says if it's not in, ignore. So basically, if it doesn't match, ignore. So let's run this. Okay. And we'll run this one. So now kube system and the OPA namespace are sort of safe from the bounds in the policy enforcement that is OPA using the Kubernetes admission controller. Finally, register OPA as the admission controller. Oh, so now we're supposed to apply this webhook configuration. Were we not supposed to apply it yet? That's admission controller. Okay, so I see. Okay, so k apply -f webhook. YAML to JSON, cat webhook on line 2. Kind, validation webhook, Let's see what this does. Error parsing webhook.yaml. Let's try this again. Cat apply webhook configuration.yaml. -f. I think I had my EOF in there. Yeah, I did an echo. They wanted me to do a cat. I'm sorry. I'm not sorry. Okay. So now that that's registered as an admission controller, you can follow the OPA logs to see what webhook request is being issued by the Kubernetes API server. Okay, so let's, I always do the wrong Control-C here. Let's clear a screen. Get back to the logs. What is -C? Container. I think this is a bad command. I think we want to do this. Is waiting. Yeah, so that command I don't think was super accurate. Maybe it was. I guess it's still starting. So kgetpo namespace OPA. Container creating. K describe namespace OPA. Let's see. Unable to mount volumes for pod. Timeout expired, waiting for volumes to attach or mount. This smells like COPS AWS volume mount issues, if I had to guess. Let's keep reading and see what we can find out. Well, we'll check chat while we're here. Great. How's everyone doing? Define a policy and load it into OPA via Kubernetes. So yeah, this is .rego. So this is rego is the name of the configuration language we're using here. Okay, so ingress whitelist. Let's see, so import data, Kubernetes namespaces, operations creator update. So deny any ingress not fully qualified domain name matches any host valid ingress host, invalid ingress host. So we want to deny ingress that are being created. Okay, so this is valid ingress host, which is defined here. So we want to whitelist anything that has a metadata annotation ingress whitelist, split that on comma, and add that to our hosts of valid hosts, and that's where we check this here. Okay, so basically what we're saying is deny anything that's not defined in this whitelist host object down here. Fully qualified domain name matches this, and fully qualified domain name matches string pattern, not contains pattern, asterisk. Okay, cool. So basically it needs to be in the whitelist and it can't be everything. Okay, so then we would create that config map, which again is just rego, and we would exercise the new policy. So we would add the ingress whitelist annotation, asterisk.qa.AmeriCorps, and production namespace star.acmecorp. We would create both of those, and we would create this ingress. I'm trying to see what's going on here. Where the host is signin.acmecorp, and this one where the host is acmecorp. And metadata ingress okay, ingress bad. And that is because... okay, so in the production namespace... Okay, so yeah, let's rewind here and see what's going on. In the production namespace, so we've created two namespaces, one that we allegedly would use for like a QA type environment, and one that we would use for like a production type environment. And the first one says, for QA, we only want to allow star.qa.acmecorp or star.internal.acmecorp. The second one says anything.acmecorp is okay. And so in this example, signin.acmecorp, this is okay because it matches this rule here, whereas this one, ingress bad, does not work because it does not match either of these whitelisted rules. I see. This is very interesting. So what is happening here is we've created two examples of namespace policy. And this is a kind of really interesting, I'm going to use that word, roundabout way of using Kubernetes annotations as a database to define what we would call a whitelisted list. So when we created the namespace, we would add this annotation ingress whitelist, knowing that we've had this ingress whitelist rego that somebody had drafted and written for us. And here's where we are pulling namespaces, input request namespace, metadata annotation. The key is ingress whitelist, which matches the key ingress whitelist and this key ingress whitelist. And we're basically saying create valid ingress hosts that we're going to assert against based on an annotation. So what this is telling me is we're able to create complex logic that we call policy using this rego programming. I don't even know if this counts as a programming language. I don't think it's Turing complete. I think this is more of a configuration language or a markdown language. And we're able to create, so in this example we have a deny subject here. And we deny everything that's not in a whitelist, and we just so happen to get the whitelist from metadata annotations. But really, we could use this for anything we wanted. We could use metadata name, we could use metadata labels, we could use the image type, we could do, I'm assuming we could do, like, there's a split function here, but we could probably do like a string contains, or a string does not contain, and we could start writing very, very specific policies and logic up here, knowing that we can enforce it down here. Interesting. So modify the policy and exercise the changes. So now they're telling us to create some conflict, and then here we have a staging namespace, and it says, congratulations for finishing the tutorial. Okay, so let's scroll up, and let's kind of bottom line this for everyone. This tutorial shows you how to deploy OPA as an admission controller from scratch. For the purpose of the tutorial, we will deploy 2 policies. Okay, so let me go back to my soapbox. Actually, let's check chat first. Taking notes. Thanks, Victor. Great. So yeah, let's go back here. I'll go to my soapbox. Okay, so basically, here's what we did. Is we went to the OPA tutorial, and we deployed OPA, which is a policy runtime engine that uses Rego to enforce arbitrary policy. And the data source that we were able to assert against was pulled from the Kubernetes API server. Whereas OPA, it looks like, could use various data sources such as Envoy, or you don't necessarily have to use Kubernetes, to create these logical data structures that you could build policy with. And so in the case of Kubernetes, in this example, OPA has implied or suggested that we would use something like annotations to create basically the data for how we're going to enforce arbitrary policy written in Rego downstream. So, I mean, of course, there's obviously some pros and cons with using annotations in this way, and there might be like more secure ways we could go about doing it, or more like robust ways we could go about doing it, such as using CRDs or config maps and GetOps, or anything for that matter. If you can get it out of Kubernetes, we can use it as a data source. Is kind of the takeaway here. Okay, so now let's go back. Now that we have a really concrete understanding of what OPA is, let's go back and let's look at Gatekeeper and see how these two things compare. So we'll go back to our full screen. Here. So now let's go back to Gatekeeper. What is OPA Gatekeeper? Okay, OPA Gatekeeper is a new project that provides first-class integration between OPA and Kubernetes. For background information, see the blog post. Let's just see what this blog post has. My blood sugar might be getting low. Hold on, folks. Let me grab some sugar. I'll be right back. Yay! Welch's Fruit Snacks to the rescue. Okay, I'm gonna munch on these while we kind of skim through this blog post here. Okay. So it says deep dive open policy agent, which this is supposed to be a blog post on Gatekeeper. Okay, Gatekeeper version 3.0 features. I did not mean to do that. Let's scroll up. Now you can take a current look at the current state of Gatekeeper to see how you can leverage the latest features. Consider an organization that wants to ensure all objects in a cluster have departmental information provided as part of its objects labels. How can you do this with Gatekeeper? So once the Gatekeeper components have been installed in your cluster, which we have done, the API server will trigger the Gatekeeper admission webhook to process the admission request, whether the resource in the cluster is created, updated, or deleted. Policies and constraints. Yada, yada, yada. As you can see with the constraint framework, we can reliably share regos via the constraint templates. Oh, so I think I see what's going on here, but I want to keep reading to make sure that I'm understanding this correctly. The audit functionality enables periodic evolutions in replicated resources against the constraints enforced in the cluster to detect pre-existing misconfigurations. Gatekeeper stores audit results as violations listed in the status field. Got it. Okay, so I think I'm gonna propose my my thesis here, my hypothesis for what Gatekeeper kind of is it's basically a set of CRDs that are very, very tightly coupled with Kubernetes that use OPA behind the scenes to enforce whatever these CRDs define. In other words, it basically does the same thing the Falco operator does, which is just creates CRDs as a way of configuring what would otherwise be just a regular OPA admission controller implementation in Kubernetes. We'll scroll back and see what we can find. Let's see. OPA Gatekeeper adds the following on top of plain OPA. An extensible parameterized policy library. Check. So far, so good. Native Kubernetes CRDs, constraints, and okay. So basically, all OPA Gatekeeper is a Kubernetes specific and tightly coupled / native, if you want to use the word native, implementation of OPA. And it configures OPA via controllers and CRDs. The API server sends the entire Kubernetes object into the webhook request to OPA. OPA evaluates the policies it has loaded, uses the admission review as input. For example, we've looked at one of these already. When deny is evaluated, the input defined below the answer is. And so here we have an admission review. Here's an example of a pod being created. The policies give you OPA ultimately generate. And we're back to queue management in OPA. Okay. So queue management is basically the piece that pulls data out of the API server and then sticks that into OPA's Rego database. Okay, so let's look at what is OPA Gatekeeper. Let's go here. Again, back to the GitHub page. How to use Gatekeeper, constraint templates, constraints. So yeah, if you remember from the whitelisted ingress example, they had us very much kind of build out a very custom system based specifically on whitelisting ingress using annotations. It looks like constraints sort of like standardize how we would just define something like a constraint, and a constraint template is basically what we would use to write that in Rego, and we just stick those in CRDs, and we're able to mutate the CRDs as our source of truth instead of otherwise like updating the config map or something else. Okay. And then of course we can use audit. Here's dry run. Kick the tires. The demo basic directory contains. I don't really think we need to go through and run this. Oh, but Rita put this together for us. So yeah, let's at least look at it because Rita asked us to do a review for her. So this will be a good opportunity for me to see what's going on here. Okay. What is demo magic and what is PE? So Gatekeeper, 2 directories up. Demo. Where's demo magic? I don't see it. So here's demo.sh. So this basically says source 1, 2, oh, it's in third party. Third party demo magic. Demo magic sh is a handy shell script that enables you to script repeatable demos in a bash environment so you don't have to type as you present, rather than trying to type the command. You know what? Let's let's run this and see what happens. Shall we? We shall. Okay, so change directory, go source, github.com. So this is OPA, Open Policy Agent. Go into there, git clone, git at github.com, open policy agent / gatekeeper .get. Change directory into Gatekeeper, go into demo, change directory into basic, sh demo.sh. Hold it, I require PV, but it's not installed. Aborting. What is PV? Let's see if we can't find it. Ugh. Monitor data through pipe. So it's called PV. So let's do Arch Linux install PV. Alright, so that looks right. Okay, downloaded. Validated GPG keys. Proceed. So now we're downloading, looks like some Python-y things. PV. Interesting. Cool. So let's go actually back here. sh demo.sh. Also, good on you, Rita, for checking to make sure I have stuff installed on my computer before running it. Okay, so here's our demo. So would I just press enter? Quebec will apply -f sync.yaml. Okay, press enter again. Oh, this is kind of handy. So you just press enter and it like types the stuff for you in a new TTY. And then it actually really will execute those bash commands. This is handy. I'm gonna use this next week at my my presentation in New York. This is really cool. Good show, Rita. Hats off to you. Cat constraints, all namespaces must have gatekeeper.yaml. Okay. Let's go back and let's see what we got going on here. So here we're catting out Kate's required labels template. So this is a constraint template. This is a very much Gatekeeper specific CRD. And here we have some rego that says you need labels. And so then we created it. And then we have all namespaces must have gatekeeper.yaml. Okay, so I think this is going to just check Kate's required labels. So this is just going to check that every namespace has the gatekeeper label. Quebec will apply constraints. All namespaces must have gatekeeper.yaml. Okay, next. Bad namespace.yaml. Error from server. Denied! Okay, so this is great. So this is using Gatekeeper as a... It's not runtime enforcement. We need to come up with a better word for this, but it's basically when you're trying to mutate something in the Kubernetes API, Gatekeeper uses OPA to enforce that you're matching whatever policy you have defined, which is super handy. So I bet now we're going to do a good namespace. Let's see. Yep. And so let's look at the bad one. So it says bad namespace. Did we already look at bad namespace? No. So I would open up a PR here to cat out bad namespace.yaml. I want to see what that is. But anyway, so now we apply the good one. And so you can see here it says gatekeeper is equal to true. So that's the label that we're asserting on, and it was created. So now Kate's unique label. Okay, so this is a constraint template that has our rego that talks about. I'm assuming this rego is going to make sure that it's a unique label, which we get all of that information from Cube Management from the API server. So now let's apply our newly created Kate's unique label template. So far, so good. I like this demo because it's showing a lot of the different things you could do with it and how it really is completely arbitrary and how you really could use it to enforce whatever you wanted to in Kubernetes. If it's in YAML, you can assert if it's there, if it matches the string, if it does something, whatever. Okay, so now we're going to all namespace gatekeeper label unique YAML. So that was created. Cat good, no dupe, namespace, gatekeeper, not duplicate. Okay, apply that, so that looks good. My one gripe is I want this to go faster now. Okay, so now let's do a bad one. I'm assuming that's what's next. Cat, okay, so yeah, so this one does cat at the bad one. So now we're trying to create a new namespace that has the original gatekeeper label, and it's gonna yell at us. So what happened there behind the scenes? Let's talk about this, because this is, here, should I go to my soapbox? Let's go to my soapbox. So what happened here behind the scenes? We created a bit of YAML that had gatekeeper equal to not duplicated. And we installed that fine, because it was the first time Kubernetes had seen that specific label. We tried it a second time. And the second time, when we tried to install an arbitrary object with gatekeeper equal to not duplicated for a label, we sent that message off to the API server. The API server called a webhook for an admissions controller, which, remember, that's how OPA is running. And remember, this is that whole lecture I gave earlier about, like, this might be magical, it might be confusing, stuff might happen, you don't understand what's going on, this might create undesired or understood behavior in your system. Which, if I wasn't specifically doing this demo, this would be very frustrating to me as a user, or as an engineer, rather, if I didn't know that we were enforcing this type of rule or policy in our system. And so anyway, we hit the API server. The API server says, okay, let's call all of our webhooks we have configured just to make sure everything's fine. It calls the OPA webhook. The OPA webhook executes the constraint template rego, asserts that against the data that we get from Cube Management from the API server, deduces that Gatekeeper has been set to not duplicated before, and therefore returns an error. The API server picks up on that error and says, no, you cannot, in fact, create this new resource. Okay, so that was kind of like the stream of events that happened there. So let's go back to our full screen, go back to my desktop, and let's see what is next. Kubectl get Kate's required. Oh, YAML, okay. You must provide labels, Gatekeeper. And so this is for every namespace in my system. Cool, so it's created this automatically for us behind the scenes. So here you can see we have default namespace, I have Falco running, we have Gatekeeper system running, Cube public, Cube system, OPA, remember we created this one earlier in the stream. And let's see I think we're wrapping up here. The end, yeah. One very intuitive demo. Thank you, Ria, for putting that together. This was really great. This really helped me understand Gatekeeper much better. I'm very, very glad I ran that demo. That was a good idea. Okay, so let's go back here to Gatekeeper. And let's see if folks have any questions. If you have any questions or you want me to answer anything or run anything before I wrap the stream up, feel free to drop them in chat. Otherwise, I'm going to get out of here for the day and try to push some of this stuff up to the repo so that we can have a little bit of infrastructure in place for our live streams. And again, we're going to start doing this more and more. So anyway, let's see what folks are saying in the chat. Doesn't look like we have anything, so I'm going to go back here, get on my soapbox. So yeah, thanks for joining. It's been real. It's been a ton of fun getting to live stream again, getting to look at OPA and Gatekeeper. And just stay tuned because this is our first one and it's going to only get better, stronger, and faster and more awesome from here. Thanks for sticking around. Thanks for watching it. Feel free to ping me on Twitter, ping me on Slack. I'm usually pretty nice depending on what I have going on and how busy I am. But yeah, I'd love to hear from you, love to get your thoughts, love to know if there's anything you want us to stream about or anything else we can look at. And yeah, if you have ideas or want to get involved, we would love to see you in the Falco channel. yeah, that's it. Thanks for sticking around. Thanks for tuning in. We'll see everybody next time we have one of these live streams scheduled, which seems to be, the pattern here seems to be when we need to take a deep dive into learning and understanding something, we're going to have me do a live stream where I can really tear into it and see what we have going on. Okay, thanks everyone. See you next time. Bye.